Yep. All right. Welcome back. We're going to do limits with direct substitution here today. So, moral of the story, big takeaway. Whenever you are doing a limit problem, the first thing that you will always try is direct substitution. So, write that down. So, here we go. So, here's problem one. So, this is the limit of a polynomial. We actually proved this one that you can do this with direct substitution. In other words, there's no need to rewrite this using limit properties. You don't have to apply the limit of a sum is the sum of the limits, limit of power of the limit, pull constants through. You don't have to do any of that. You literally can just chuck in -2 where you see an x. You get 2, and then times -2, that's me chucking it in, -4 times -2 plus 1, and just kind of crunch the numbers here. So -2 cubed is going to be what? -8 times 2, -16. It's going to be +8 plus 1. You're going to get -8 here, and then plus 1, -7. So your answer is -7. But again, understand what it is you're actually doing, right? As your x values, as your inputs get closer and closer and closer to -2, right, your y values, your functional values, are approaching -7. So I'm not going to take the time to accurately sketch this, but hey, it's a cubic function. Now, who knows? Maybe it looks something like that, right? And as I go, and who the heck knows where -2 is? It could be here, here, here. It actually doesn't matter, right? So maybe there's something like this going on, and -2 is like over here, right? So as x goes to -2 from both the left and the right, my corresponding functional values will be approaching this value here, which is going to be -7, okay? Realize I did that kind of quick and didn't do the actual graph, but just go ahead and graph it on Desmos and you will see exactly what I'm talking about. All right, so direct substitution, always the first thing you try. Now, we proved it with limits, but it turns out that it worked, not limits. We proved it for polynomials, but it turns out that it works for a lot more than just polynomial functions, all right? It has something to do with whether or not the function is continuous or not, all right? But we'll get into that in a little bit. So let's keep going. So let's do the limit of this function, the limit of arctangent of x as x goes to 1, right? So again, moral of the story, the first thing you will always try in a limit problem is to directly substitute. So I will plug 1 in for x, and then I'm going to get arctangent of 1. Now notice, guys, I didn't write limit of arctangent of 1 as x goes to 1. The instant you chuck the value in, stop writing limit. Okay, same thing here. As soon as I chucked the -2 in, stop writing limit. You're actually doing it. Okay, drives me insane when people continue to write it. So now arctangent of 1 is your answer. Now, if you hopefully you know what the arctangent of 1 is, but if you don't, then this is what you're going to have to go with, and hopefully you get partial credit. All right, but to simplify the arctangent of 1, give me an angle whose tangent is 1, right? Calculus, we're always in radian world. That's going to be pi over 4, right? Because the tangent of pi over 4 is in fact equal to 1. And that's a memorization thing. And I'll actually make a short little video on the things that you're supposed to have memorized in terms of, trig values. All right, so let's just rock and roll here. And again, I apologize because this really isn't going to be the most exciting, but it is necessary. So let's do the limit as x goes to -2 of x squared times 2 minus x. Again, I do not need to rewrite this using limit properties. I don't have to do the limit of product of the limits, limit of power of the limit of difference of the limits. I don't have to do any of that. I can literally just directly substitute, right? So here I go. I'm going to -2. I'm going to chuck -2 in for the x. And I'm going to get this. So -2 squared, that's just going to be 4. And then 2 minus -2, that's also going to be 4. And then so I end up getting 16 there, okay? 2 is horrible here. So again, don't lose sight of what you're finding. As your x values, as your inputs get closer and closer to -2 from both the left and the right, your corresponding functional values right here are going to be approaching 16. Okay, again, as soon as you chuck -2 in, stop writing limit. All right, not very exciting. Let's do a couple more. Let's do 4 here. Let's do the limit of the sine of 3x as x goes to pi over 6. Again, first thing you try to do is directly substitute. So I'm going to go ahead and chuck in pi over 6 where I see an x. Notice as soon as I substitute it in, I stop writing limit. And now, all right, what do I get? 3 times pi over 6, that's going to be pi over 2. Again, these are the things you have to have memorized, right? North pole, unit circle, y value, what is it? It's going to be 1. So the sine of pi over 2 is just 1. And so that's my answer. Again, not losing sight of what I'm doing. This is my function. As my x values approach pi over 6 from both the right and the left, my functional value will be approaching 1. This would be a great one to do on Desmos, all right, to see it graphically. Okay, let's take a look at 5, the last guy here. Limit as x goes to 1 of x squared plus 2x plus 4 over x plus 1. All right, so this is actually not a polynomial. If you listen to that video, maybe you picked up on it. This is a polynomial divided by a polynomial. And when you have a polynomial divided by a polynomial, we call that a rational function. Well, it turns out you can directly substitute into those guys as well, provided you don't get anything that's undefined. So let's go ahead and chuck in. So let me chuck 1 in up top. So that's going to be 1 squared plus, that's supposed to be a 2. My pad's going a little bananas, so it's making things look funny. 2 times 1 plus 4 all over 1 plus 1. Notice, what don't you see over here? Hopefully you said you don't see limit. Yeah, because I directly substituted 1 in, so I stopped writing that. And then I just compute this. So you got 1 squared is 1, plus 2 is 3, plus 4 is 7. Bottom's 2. You get 7 over 2, 3.5. Call it a day. All right, so let's just for fun, actually, you know what, I'm not going to be able to do because it's locked in the screen. So that's it. So that's 5 direct substitution problems. In the next video, when we start to do more limits, I'll actually do the graph along just so you can always keep that connection in mind. But that's direct substitution. First thing you try in a limit problem, you know what it is? Give you 3 seconds to answer. 1, 2, 3. You should say direct substitution. It's the first thing you always try when you're trying to do a limit. Okay? All right. Be good. Talk to you soon.